Okay, so this warm-up is reviewing factoring. If we look at number 1, both of these terms have a common factor. They are both divisible by a 3, and they both have at least an x cubed. So we would start off by dividing each of these terms by 3x cubed and factoring out that greatest common factor. So we go here and we divide each one by 3x cubed. When we do that, we then will have 3x cubed on the outside and 4x squared minus 3 on the inside. This does not factor any further, so it is factored completely. On the second problem, we have a 4x squared, a 12x, and a 16. This makes this a trinomial. We still need to check for the GCF first. All three of these terms are divisible by 4. So we would start by dividing each term by 4, like so. That would result in 4 times x squared plus 3x minus 4. Now, this is not done yet because this trinomial can be factored again. Remember that what we do is we look for numbers that multiply to negative 4 and add to positive 3. So if we're looking for a pair of numbers that multiplies to negative 4 and adds to positive 3, there are only two options. 1 and negative 4, which would add up to negative 3, and negative 1 and positive 4, which would add up to 3. So the pair that we want to use is negative 1 and positive 4. This other 4 from the GCF is just going to stay out in front of the answer. So that will break into two binomials, x minus 1 and x plus 4. That is now factored completely, and we move on to number 3. On number 3, this trinomial does not have a greatest common factor, so we should be going straight to numbers that multiply to 225 and add to 30. Now there's a number of pairs for this problem, so we'll get all of those written down. 3 and 75, 5 and 45, 15 and 15. And then we go in and we add each of those pairs of numbers together to see which one adds up to the number that we need. Now if you notice, these numbers are getting closer and closer to our goal. Once we find the number that we want, we don't need to continue the table. So our two numbers we're looking for are positive 15 and positive 15 because those are the numbers that multiply to 225 and add to 30. So we would break this trinomial up into two binomials. Each would start with x, and then we would use these numbers down here, 15 and 15, to complete those binomials. Now the reason that this example is here on this warm-up is to remind us that if these two binomials are the same binomial, which they are, they're both x plus 15, our final answer in proper mathematical notation would be the quantity x plus 15 squared. That only happens when the factors are the same. That means this trinomial is known as a perfect square trinomial. Not going to be important yet, but later in Algebra 2 we will need that term. Now on number 4, we have a greatest common factor of 3x. So we're going to factor that out first. Remember that when we take out the GCF, we are dividing each term by the GCF. Now you don't necessarily need to show this step if you understand that. But until you do, you should be showing that work. That would reduce to 3x times the quantity x squared minus 9. Now we're not done yet because this binomial is a special kind of binomial known as a difference of two perfect squares. X squared is a perfect square because its square root is exactly x. And 9 is a perfect square because its square root is 3. They're being subtracted. That is why it is called a difference, which is subtraction, of two perfect squares. So just like the 4 earlier, the 3x is going to sit out in front, and this binomial is going to factor. It's going to break into the square root of the first term, square root of x squared, which is x, plus or minus the square root of the second term, which is 9. Square root of 9 is 3. So that would be the factored form of that trinomial.